This is question 53 of chapter 9 in our physics textbook, and the question basically reads that a 140-gram baseball is moving horizontally to the right at a speed of 35 meters per second. At that point, it's hit by a bat. The bat, once it's hit by the bat, the ball flies to the left at a velocity of 55 meters per second at an angle of 25 degrees above the horizontal, and it wants to know what's the magnitude and the direction of the impulse that the bat delivers to the ball. So in order to do this, we have to solve for a couple things. Our final equation that we want to use to determine the magnitude of the impulse is this equation here, that the impulse equals the momentum of the final minus the initial momentum in vector notation. So to get to this point though, we have to figure out our x and y values for both our initial momentum and our final momentum. So to do that, we can start out with working with our initial momentum. And so in vector notation, we have to indicate our y and x value. So we're given our x value for the velocity, which is 35 meters per second, and since it's going to the right on a horizontal line, it's positive. So we have our 35 meters per second, and then for our y component, because it's traveling on the horizontal, it doesn't have a y component, so it will be 0. And then we'll need to times that by the mass of the ball, because our momentum is equal to our mass times our velocity. So the mass of the ball was given in grams. It was stated at 140 grams, which once we convert that to kilograms, we get 0.14 kilograms. At this point, all we need to do is times that together, and we should get for our initial that our P initial in vector notation should equal 4.9 meters per second, and then still 0. And so that's our P initial, but we need to solve for our P final. So to do that, we need to take the information that was given. So to do this, we've kind of optimized the information in a chart, which will help us to work through the problem. So we know the degree is given was 25 degrees, and we know that we have, if we create a triangle, we basically have the hypotenuse side of the triangle, but we need to solve for this y value and this x value. And so to do that, we can use cosine and sine in order to get our desired lengths, or sorry, our desired x and y components. So to do that, we enter it into this equation here, and this will be for our x component. And we know that the final velocity on the x component is going to be negative, because if it got hit to the left, it's traveling in the reverse direction on the horizontal. It's traveling to the left, so our value will be negative. So we can use this equation. Our final velocity x component equals the negative final velocity times the cosine of our angle, which if we enter in our information, we get negative 55 meters per second, cosine 25, which will basically give us an x component of negative 49.85, and that's for our x component. Now we have to do the same thing for our y component, and to just save some time, I'm just going to give you the final value, but it's run in the same manner as this equation, but this velocity will not be negative because it's on the y-axis and it's going up, indicating that it will not be a negative sign. So once we do the calculation for the y component, we get 23.24. And now at this point, we have our velocity the x and y component of our final velocity for the final momentum, but we need to times those values by the mass of the ball in order to get the momentum. So what we have to do is basically the same thing down here, but to our x and y. So we get something that looks about like this. Grams times by our x component and our y component, which should give us x and y components of negative 6.972 and 3.248, which will be in vector notation the momentum x and y for our final momentum. And so now that we have both our vector notation momentum for the final and our vector notation momentum for the initial, we can just input them into this equation, which will give us our impulse. And so once we do that, we'll get and because the value is 0 over here, our y component basically stays the same, so we still get 3.248, but our x component now is negative 11.872. And so once we have these, we can plug it into an equation that will give us our magnitude of the impulse. And that equation is basically that the magnitude of impulse is equal to the square root of our x squared plus our y squared, which will give us a value of 12.32 kilograms times meters per second. And that's the magnitude of the impulse from the bat. And so now to find the degree of impulse, what we need to do is we have our x and our y for the impulse. So what we need to do is use inverse tangent, which will give us the angle here. So we just need to enter in our x, which would be the 3.2, because when you use tangent, it's opposite over adjacent. So we get our y component on top, our x component on bottom, and it's the absolute value of that, so there will be no negative in the end. But once we run that through a calculator, we should get approximately 15 degrees. And that should be our degrees of impulse. So we now have our magnitude and our degree of the impulse that the bat delivers to the ball. And that's how you do this problem.